All right, y'all, today we're going to be talking about section 3.2, Rolle's theorem and mean value theorem. What I want you to know is that Rolle's theorem is just a special case of the mean value. And mean value, we can abbreviate MVT. That is totally acceptable. So go ahead, pause, copy this formal statement of Rolle's theorem here, and then come back so that we can talk about it. All right, so if we're looking, right, if f is continuous, one, continuous, all right, two, it has to be continuous on the closed interval and differentiable on the open, okay? So continuous on the closed, differentiable on the open. Commit that to memory. You need to have this theorem memorized, all right? If on that interval a to b, we have f of a equal to f of b. So for example, graphically, that would look like this. See how they have the same y value at both a and b on this curve. So if f of a is equal to f of b, then there exists, that's what that backwards e is, at least one number c in this interval such that f prime of c is equal to 0. So what we're saying is because the curve is going to have to do something between those 2 points and it's continuous, it's going to have to turn somewhere. And even if it was horizontal, right, the derivative of a constant would still be 0. So what this means is that because f is continuous and differentiable, we know that at some point in between a and b, f prime is going to be equal to 0 because there will be a horizontal tangent. All right? So now let's go ahead and do an example. So looking at example 1, all right, this is illustrate Rolle's theorem. So first we have to state whether or not the two conditions of Rolle's theorem have been met. First condition, f is continuous on the closed interval. F is a polynomial, so obviously it's continuous everywhere, so it will be continuous on this closed interval. 2, polynomials are differentiable everywhere, so we will both be continuous on the closed and differentiable on the open, all right? So the directions here tell us to find the two intercepts, all right, of f of x. So go ahead right now and find your x-intercepts by setting f of x equal to 0, pause the video, and then come back to check and make sure you're good to go. All right, so you just found your x-intercepts. You should have found them to be 1 and 3, okay? So now 1 and 3 will be how we define our interval. So now we're going to say because f of 1 is equal to 0 and f of 3 is equal to 0, then there's going to exist some f prime of c in that interval where the derivative is equal to 0, all right? So because both the endpoints of our interval have the same output, there will be some c value where the derivative is equal to 0, meaning the curve will have a horizontal tangent somewhere. So now we're going to, in step 3, set the derivative equal to 0 and solve. So go ahead, differentiate f of x, set it equal to 0 and solve, and then come back to check. All right, so you should have solved and gotten x equals 2. So now, using Rolle's theorem, we can conclude that f prime of 2 is going to be equal to 0. And so this is how we're going to state that, all right? So f prime of x is equal to 0 when x equals 2, and 2 is contained in this open interval. All right, so let's just recap, right? Step 1, we have to state that the function is continuous on the closed and differentiable on the open. Then we found our x-intercepts, which are going to bound, all right, that's going to define our interval, and the y outputs of each endpoint of our interval are equal, which means then that some f prime of c will equal 0. So then we differentiate and set the derivative equal to 0 and solve. And this is the x value where the derivative will have a value of 0. All right, now let's go ahead and continue to another example. So for this one, we have f of t equals negative t to the 4th plus 2t squared, all right? And we're finding all values of c in the interval. So in this closed interval, negative 3 to 3, that f prime of c is equal to 0. So step 1, we have to state whether or not our function is 1, continuous on the closed and differentiable on the open. Again, we have a polynomial, so yes, it is. So you can pause and write that out. So this is what we're going to have. All right. If this is true, then we have to show that the y value for each endpoint of our interval is equal. So now go ahead, and for number 2, you're going to find f of -3 and f of 3 and show that those are equivalent. So pause, find f of -3 and then f of 3. All right, you just found that they were both equal to -36. So now there must exist some c value on that interval such that the derivative is equal to 0. So now go ahead and differentiate, set your derivative equal to 0, and solve for t. So pause and then come back. All right, so you should have solved and found that. All right, you have 3 t values, all right, where f prime of t is going to be equal to 0. So now we can say by Rolle's, f prime of t equals 0 at x equals -1, 0, and 1 on this open interval -3 to 3. All right, so Rolle's theorem is an existence theorem. It's telling us that the derivative at some point on an interval is going to equal 0. Let's continue to now one of the big theorems of calculus. This you absolutely have to memorize. Star it, circle it, do something. That's why I did it in hot pink and purple, all right? And you can abbreviate this MVT. That's totally acceptable. Pause, copy this, and then come back so that we can discuss. Okay, y'all, you've copied this down. So let's go ahead and look at the conditions of the mean value theorem. So if f is 1, continuous on the closed interval, 2, differentiable on the open interval. Notice how those are the same conditions as Rolle's, all right? There exists a number c in our open interval such that f prime of c is equal to, this is the slope of the endpoints, right? This is the slope formula. So slope of the endpoints, right? Which is basically saying that instantaneous rate of change, meaning the derivative, is equal to average rate of change on that interval, all right? This is a huge theorem in calculus. You have to have this memorized verbatim, all right? So basically what it's saying is that if I look at this graph, if I have, these are my 2 endpoints, right? So this is A and this is B. Then the slope between them, this curve that's continuous, will have to have some point on it where I was actually traveling at that average rate of change, at that speed. All right, so now let's go ahead and look at the example. All right, so example 3, all right, we're given f of x, right, and it says find all values of c in the open interval 1 to 4 such that f prime of c is equal to the average rate of change, which we can also abbreviate average rate of change, AROC. Okay, so step 1, we have to state that the conditions of MVT have been met. So 1, is the function continuous on the closed interval? 2, is it differentiable on the open? And yes, it is, all right? So we've met that. Step 2 is now you're going to find, all right, the slope between the endpoints of the function. So go ahead and calculate f of 4 minus f of 1 over 4 minus 1. So go ahead, do that, pause the video, come back. All right, so this is what you should have gotten, 5 over 4. All right, so now what MVT tells us is that average rate of change, our slope, average rate of change, which we found to be 5 over 4, there will be some c value where the instantaneous rate of change is equal to our average rate of change. So now you're going to differentiate and find f prime of c, and then you're going to set that equal to 5 over 4. So now go ahead, set that equal to 5 over 4. All right, so here we have 2 answers, right? So x is equal to plus or minus 2, all right? Which means then by the MVT on that interval, f prime of plus or minus 2 is equal to 5 over 4, meaning that when x is both positive and -2, the instantaneous rate of change is equal to the average rate of change over that interval. All right, we're going to recap both 3.1 and 3.2 next class. Have a good weekend, and I will see y'all on Tuesday.